Assalamualaikum. Alright, so in this video we are going to look at the 0 over 0 case of the limit where we have to use the squeezing theorem. So before we could go to the squeezing theorem, you should know some properties of the limits actually. Alright, so let's say we have the first one. If you have limit of fx plus gs, so we can separate them, so it will become limit of fx plus limits of gs. So the same goes to the operation of subtraction. Right, if you have limit of fx multiplied with gs, so you can have actually limit of fx multiplied with the limit of gs. So in this case, that dot means multiplication. All right, so let's go to number 3. All right, if you have limit of fx over gx, all right, so you will have something like limit of fx over limit of gx, but with the condition where gx, limit of gx shouldn't be 0. All right, if it is 0, so we can't use these properties. Okay, so we have the last one. If we have the limit of k fx where k is a constant, so we can take out the k outside the limit, so we put k in front here, so we'll have limit of fx. So we should note that the 4 properties here will be used a lot in the case where we want to use the squeezing theorem. Alright, so before we could go to squeezing theorem, right, so the squeezing theorem comes from the the problem where we have limit of x as limit of x approaching 0 of sine x over x. So if we try to substitute with we directly substitute x with 0, so we'll have something like, alright, so sine 0, so it will be something like sine 0 over 0. So what is sine 0? So recall the sine graph will be something like this. So sine 0 is here, so the value is 0. So sine 0 is 0, so this is actually 0 over 0 case. So that's why we have to use the squeezing theorem, where in the theorem states that if we have limit of x approaching 0 of the sine x over x, so the value will be 1, not 0 over 0. Why? Because if we have the limit, the graph of a sine x over x, so this is the graph of y, which is equal to sine x over x. All right, so we'll have something like this where we have whole here. So please take note that it is whole means the function is not defined at x equal to 0, but because we are looking at the limit, so as x approaching 0, so the function will approach the value 1, right? So the function is not defined, but the limit is there, is still the value is 1, right? So the limit exists where the value is 1. So please memorize this squeezing theorem. All right, so please memorize this. Okay, so let's move to the first problem. All right, so what if we have limit of x approaching 0 of sine 2x over 2x, right? If you, this is actually we want to utilize the squeezing theorem where the value is actually 1, so the final answer will be 1. But how do we do this? If later on you will know how. But if you have limit x approaching 0 of sine 3x over 3x, it will be 1. All right, but if it is not the same if we have limit of x approaching 0 of sine 2x over x. Right, so this is not the same. You cannot simply conclude that the answer is 1, right? You have to do some operations there, right? So all right, I'm trying to use substitution. All right, in this case, all right, let's say we let t will be 2x. So when x approaching 0, so of course t will approach 0, so we can try to substitute that. So limit as, all right, so x approaching 0 will be substitute with t approaching 0. So we have limit as t approaching 0 of sine 2x will be t. All right, so sine t over t. So this is actually the squeezing theorem where it states that the value will be 1. All right, so this is the basic idea of how I do this. But never mind, you don't have to show this substitution method in the solution. You just simply use the squeezing theorem, which is 1. All right, let's move to number 2, where the problem here is that they have 2 inside here, but they don't have 2 out the denominator. So most of the students would take out this 2. That's the wrong concept, all right? So they simply take out like 2 sine x over x. So this is wrong. They cannot do this, right? Because you cannot disturb the angle. I call this part as the angle of this sine function, right? You cannot disturb that. You cannot change anything there. What you can do is that your intention is to make, all right, if you have 2x here, so you must have 2x there. So how do you make the 2x exists there, right? So let's say I copy first. Okay. All right. Let's say you have limit as x approaching 0. All right, sine of 2x over x. All right, so how do we put 2? All right, you cannot simply put 2 there, right? It's wrong, right? Because where does this 2 come from? All right, so you can put 2 with one condition. If you put 2 here, and you must put 2 here also. Why? Because 2 over 2 is 1, so it goes back to this, right? So you can simply put 2 at the denominator and put 2 at the numerator, right? So now, all right, so we have learned in the properties of the limit where we can take out the constant. This is the constant in front of the function, so we can take out it in front there. So we put 2 here, right? So we'll have limit as x approaching 0. So we'll have sine of 2x over 2x, right? So we know that this will be 1 by squeezing theorem. So this is 1 by squeezing theorem, right? So please take note, we're gonna use squeezing theorem quite a lot. So I'm gonna write in short there, theorem. So we'll have, all right, 2 in front there. Okay, don't forget that we have 2 in front here. All right, so by squeezing theorem, it says that the value will be 1. All right, this part will be 1. All right, so 2 multiplied by 1. Please show that by using squeezing theorem, you get the value is 1. All right, most students just ignore the value 1. All right, I know it's very easy to multiply 2 by 1, so but you must show, right? So 2 multiplied by 1 will be 2. Okay, so this is the full solution for question number 2. Right, let's move to number 3. Right, different from what we have in number 2. Now we have the value here. All right, can we take out this 3 in front here? Yes, because that's not the angle of the sine function. We can take out that 3. So we'll have something like, all right, so let's say I copy first. Limit as x approaching 0 of sine x over x. So I take out that 3 in front here. So I put it here. Is it correct? No, it's not correct. Why? All right, so look at 3. So this 3, right, this 3, I'm going to highlight it. This 3 at the denominator. So when you take out outside the limit, so it should be at the denominator. So it should be something over 3. What is it? It's actually 1. 1 over 3, so something like this. Okay. So it's actually 1 over 3, not simply 3. All right, so you have 1 over 3 limit of x is equal to 0 of sine x over x. So by squeezing theorem, again, by squeezing theorem, you don't have to write that, right? But I'm writing here so that you have the idea where does the value come from. All right, so squeezing theorem says that the value will be 1. All right, so you have that 1 over 3 there, and then you have from squeezing theorem you get 1. Please show that it will be 1. All right, so 1 over 3 multiplied by 1 will be 1 over 3. So your final answer will be 1 over 3. Okay. All right, so let's move to number 4. Right, so if you have something like this, all right, for some students this will be quite complicated, right? All right, so my advice always, if you have something like, all right, this is 1 over 3, this is 2, they're completely different. So what I'll be doing first is actually I'll take out these 2 outside. It will be 1 over 2, not 2. All right, please remember from previous examples. So it is actually 1 over 2. All right, so we'll have that limit as x approaching 0 of sine 1 over 3x over x. All right. Okay, so we have something like this, but we have that 1 over 3 here, right? Can we take out this 1 over 3 outside here? We cannot do that because that 1 over 3x is the angle of the sine function. We cannot change anything on the angle. What we can do if we're trying to make something the same here, all right? You have 1 over 3x, so we want to have 1 over 3x here, all right? So we just simply put 1 over 3, but where this 1 over 3 comes from, so you have to put 1 over 3 in front here. Why? Always, if you want to put something on the denominator, and you have to put it the same thing at the numerator, right? Because initially it does not exist because you cancel this, all right? We go back to the initial function, all right? So we simply put that, all right? So now again, we have to take out this 1 over 3. We take out this 1 over 3 out there, so we'll have something like, all right, so let's say I have 1 over 2. Now I take out 1 over 3, it's simply multiply 1 over 3, right? Or you can put in bracket. And you have now limit of x approaching 0 of sine 1 over 3x over 1 over 3x. So that's simply squeezing theorem. So this part is actually using the squeezing theorem. So we'll have, all right, so 1 over 2 multiplied by 1 over 3 multiplied by 1 by squeezing theorem. I'm not writing the squeezing theorem there. Right, so you can get the final answer by simply multiply the numbers. So you can get the final answer as 1 over 6. Okay. So that's not difficult. It's just that you need to play around with some kind of algebra, and no, not that algebra. It actually is kind of fractions, and it's just a form of numbers. All right, why do we have something like this? All right, if you try to substitute with x with 0, so we'll have something like 0 over 0. Okay, so my advice always, if you have the number in front here, you can take the out 0. So we'll have something like, okay, so I'll have something like 2, okay, limit of x approaching 1 of sine x minus 1 in the bracket over x minus 1. All right, so actually this is this is actually the squeezing theorem. All right, so as we have seen just now, the graph for sine x over x is something like this. But if you shift the graph, if you've taken MAT183, the pre-calculus, so you should know this. But if you haven't taken, but never mind. If we have something like a function that if we subtract it here, all right, so this function, all right, if we subtract that x minus 1, meaning that we have to shift the graph of sine x over x, we shift to the right. So the graph, the original graph is actually in red. All right, this is sine x over x, but when we have x minus 1 sine x minus 1 over x minus 1, meaning that we have shifted the graph of the red graph there to be the blue graph. We have shifted to the right by 1 unit. All right, so we have shifted to the right by 1 unit. So the graph in blue is actually the graph of sine x minus 1 over x minus 1, right? So as x approaching 1, so we take note that when x approaching 1, right, when x approaching 1, so the value will approach 1 also here. All right, so in this case, this is actually the squeezing theorem. All right, so you'll have something like 2, all right, multiplied by 1 by squeezing theorem. All right, so this is actually simply squeezing theorem. Okay. All right, so 2 multiplied by 1, so your final answer will be 2. So this is the solution for question number 5. All right, let's move on to number 6. All right, we have something like this. If we try to substitute x with 0, so we get 0 over 0 case. So what you need to do is you can simplify these expressions first. So we have something like, all right, so limit as x approaching 0 of x squared over x plus 4 sine 3x over x. Okay, so please take note that this can be simplified, all right, and we can use the properties of limit where the addition will be distributed with the limit. All right, so limit as x approaching 0 You simplify this one, x squared over x will be x plus, all right, so now I'm going to distribute this limit as x approaching 0 to both terms. So we'll have something like limit as x approaching 0, and here also we'll have limit as x approaching 0 of 4 sine 3x over x. Okay, so again, if we have something like constant here, we can take it out, and for this one we can simply substitute with 0, so we'll get 0. All right, there's no problem with substituting there because we can simply get 0, which is a value there. All right, so now we'll have plus. Okay, I take out 4 in front here, so 4 limit as x approaching 0 of sine 3x over x. All right, so please take note that we have this 3x here, but this is only x in denominator, so we cannot take out this 3 outside. We cannot do that. All right, so what we can do is that we want to make them the same, so we want to have 3x in the denominator, so we put 3 here and we put 3 in the numerator. So now again, you can simply take this 3 out. All right, bring this 3 out here. All right, so 0 will be ignored there, so 4. All right, this one also you must be careful where the 3 will be taken out, will be multiplication, not simply 43. No, all right, that's you might think that you might look at it it's funny, but some of you will probably do this in the exam or even test. So it should be multiplied, 4 multiplied by 3, not simply 43. All right. Okay, so you'll have limit as x approaching 0 of sine 3x over 3x. So this will be using the squeezing theorem. So you'll have 4 multiplied by 3 multiplied by 1 by squeezing theorem. So the final answer will be 12. Okay, all right, it's not that difficult. All right, it's just that you have to play around a little bit. All right, so what about the function when it involves tangent? Also in this case, when you try to substitute x with 0, you get 0 over 0 case. So when it involves tangent, so you have to convert to something which contains the sine function. So we note that the properties of tangent, if we have tangent x, all right, please take note, if we have like tangent x, so we'll have actually sine x over cos x. So I always memorize it as t as c, right? So t as c. So tangent is actually sine over cos. So in this case, tangent 6x will be converted into, right, so limit as x approaching 0. Right, tangent will be, right, sine 6x over cos 6x. What about this 3x? So this 3x is actually, all right, so you can put it as, all right, so how do I write this? All right, so let's say, all right, I want to simplify it as x approaching 0 of tangent 6x. All right, if we want to put the 3x at the side, so it will be 1 over 3x. Am I right? Okay, so now in this case, we have converted into this, and we have that 1 over 3x at its side, right? So it will be multiplied by 1 over 3x. Okay, so we have the 1 over 3x. All right, so now we can simply put them together. Okay, I can even put them as separately. All right, so something like sine 6x over 3x. I can even put it, all right, cos 6x. Maybe some of you will be questioning, never mind. But please take note, if you want to utilize the squeezing theorem, so we want to let something like sine x over x. So we want this green part only. So we have to put that cos 6x apart, all right? So what we need to do is actually we have to simply write it in terms something like this. Limit as x approaching 0 of sine 6x over 3x multiplied by 1 over cos 6x. All right. So now please take note that we want to have something like 6x in the denominator. So how do we do that? So to do that, you have to multiply by 2. All right, so multiply by 2 here, and you have to multiply by 2. Only then you will have 6x in the denominator. So we'll have something like, okay, limit as x approaching 0, 2 of sine 6x over 2 multiplied by 3 will be 6x. Okay, and I want to distribute the, what do we call that, the limit. I want to distribute here and also here, because using the property of the limit we can distribute if it involves the multiplication. So we'll have something like, right, so limit as x multiplied by limit as x approaching 0 of 1 over cos 6x. Right, so we'll have something like this. Again, we can take out this term, sorry. Again, we can take out these 2. All right, so put it in front here. So it will be something like 2 limit as x approaching 0 of sine 6x over 6x. All right, so for that part, you can simply substitute the value of x is 0, because if you try to substitute the value of x 0, cos 6 multiplied by 0, so cos 0 is 1. Please take note that cos 0 is 1, not 0. Right, so now we'll have something like, all right, this one is 2, so this part will be 1 by squeezing theorem, and this one will be, all right, multiplied by 1 over 1. So we'll have 2 as the final answer. Okay, so let's move to question number 8. All right, so if you have something like this, all right, again, if you have a tangent x, so you should be changing it into sin x over cos x. All right, so for this one is very simple, I think, because we have, all right, for example, in this case, limit as x approaching 0, a sine of x, so tangent x should be converted into, right, so that tangent x will be simplified into sine x over cos x. All right, so we try to figure out this one. All right, so limit as x approaching 0, right, that sine x actually divides the cos x, sorry, divides the sine x over cos x. So when you have division where together with your fraction should be converted into multiplication, but the fraction should be inverted, right? So something like sine x multiply cos x over sine x. And now you can see that this one can be cancelled out, right? So we'll have something like limit of x approaching 0 of cos x. So you try to substitute the value of x with 0, so cos 0 will be 1. That's your final answer for this one. Right, so let's see number 9. Limit of x approaching 0 of sine 3x over tangent 7x. So you try to, again, we have to convert this one into sine over cos. So we'll have something like limit of x approaching 0, sine 3x, that one will be changed into sine 7x over cos 7x. So this one is quite challenging, right? So please focus here. Right, so this one will be changed. All right, so you can show one by one here, or you can just simply write it as, all right, so limit as x approaching 0. This one will be sine of sine 3x over sine 7x multiplied by cos 7x. All right, yeah, you just need to do this step. All right. Okay, so now you have sine 7x over sine 3x over sine 7x. All right, so you cannot do anything. You cannot do anything there. because we want to use, if you want to use this squeezing theorem, it should be in the form of sine x over x, right? So but we don't have this part here, we don't have that x there, so we can put them, all right, we can put that x there by simply, all right, so let me write it here. All right, so limit. All right, so what I'm gonna do in the next step is that I want to distribute this limit into these two functions. All right, so it will be limit as x approaching 0 of sine 3x over sine 7x. All right, and then we multiply with that one I'll write it in purple. All right, so multiply by limit as x approaching 0 of cos 7x. All right, so now I'm trying to add that we try to multiply with 1 over x, but you cannot simply put 1 over x there. If you multiply 1 over x at the numerator, so you have to multiply the denominator with 1 over x, right? So we'll have something like this. So now I'm gonna distribute this limit again, where the function where the limit will be distributed at the numerator and also denominator. So you will have something like, all right, so limit as x approaching 0 of sine 3x over x, all right, the whole thing, over limit as x approaching 0 of sine 7x over x. All right, so for that part, all right, so don't forget the one at the back there. You just simply substitute that with 0, so you get cos 0. Cos 0 will be 1. All right, so for this part, all right, we have 3x there, but we don't have 3 at the denominator, so we can simply put 3 here, but we have to put 3 also. We can put 7 here, and we have to put 7 there. All right, in the next step, what I'm going to do is to bring this 3 and 7 out of the limit. All right, so we'll have something like this, that 3 over 7 will be 3 over 7, right, the whole thing over. So I'm writing that, right, limit of x approaching 0 of sine 3x over 3x. At the denominator, we limit as x approaching 0 sine of 7x over 7x. So that cos 0 will be multiplied by 1. All right, so now please take note that the one that I'm highlighting in yellow color here will be 1 by squeezing theorem. All right, so we will have something like, all right, 3 multiplied by 1 over 7 multiplied by 1 multiplied by 1. So your final answer will be 3 over 7. That's why I say this one is quite challenging. All right, so you just need to do it slowly and carefully without doing any mistake. All right, so let's move to number 10. All right, so for number 10, okay, please take note that we have x here, but we have square root x there. All right, so the first step, we can take this constant out of the limit first. So we'll have something like 1 over 3. All right, so I'm writing the limit as x approaching 0 in black color of sine x over square root x. All right, so we cannot simply put square root there. We cannot. Where does this square root come from? No, the question is not given it a square root. All right. So now, what we can do is to cancel that square root, you have to multiply with the square root. You multiply this one with square root, because square root x multiplied by square root x, all right, will be square root x squared. Square root x squared will be x. So the square root is no more there. So, but you cannot simply multiply that square root x there. If you multiply square root x at the denominator, you have to multiply the square root x at the numerator also. So we'll have something like this. So we'll have 1 over 3. All right, so limit as x approaching 0 of square root x sine x over, all right, so this part will be x, so over x. Right, so now I'm trying to distribute the limit as x approaching 0 into this function and also this function. So we'll have something like, all right, 1 over 3 limit as x approaching 0 of square root x multiplied with the limit as x approaching 0 of sine x over x. Alright, now we're trying to use the squeezing theorem. Alright, so this one, 1 over 3 multiply that. Alright, so we are trying to substitute the value of x with 0 here, right? This part. Okay, so we'll have something like square root 0. Alright, we have square root 0 for that part. Now that one will be using the squeezing theorem will be 1. So square root 0 will be 0. So 1 over 3 multiplied by 0 multiplied by 1. So your final answer will be 0. Please don't write 1 over 3, don't write 1. The final answer should be 0. Okay? Alright, so yes, I know you have been tiring, you were tired of calculating this, but the final answer will be 0. You know, in life, that's sometimes it's like that. You just have to accept it. Just follow the flow. Okay? Alright. So let's look at number 11. You have something like this. Alright, if you try to substitute x with 0, so you get 0 over 0 case. So again, if you have tangent, alright, so the tangent should be converted into sine over cos. So you will have something like, alright, limit as x approaching 0 of the x cos x over the whole thing will be tangent x will be converted into sine x over cos x. Alright, so this should be simplified as, alright, limit as x approaching 0 of we have something like x cos x over sine x multiplied by cos x, right? So please take note that we want to leave the x with sine x alone and put that cos x alone. So what we're going to have is something like limit as x approaching 0 of x over sine x multiply with the limit as x approaching 0. Alright, I'm distributing the limit into the two functions of the cos square x, because cos x multiplied by cos x will be cos square x. Alright. So you have this, alright, but this one is something similar, something quite similar to the squeezing theorem, but it's not squeezing theorem. You cannot simply use the squeezing theorem yet. Alright, so what you have to do, if you have to put that sine x over x. So how are you going to do that? Alright, so actually, right, this can be changed into, I'm writing in red color here, alright. So let's say we have our limit as x approaching 0. So to change that x over sine x, you cannot simply change sine x over x there, but you have to put 1 over sine x over x. Why? Alright, so why? Alright, let's say 1 over, okay, if we have something like 1 over a over b, this is actually 1 divided by a over b. So this is change into 1 over b over a, so multiplied by b over a, so we have b over a. So b over a can be changed into this form. So same goes here, right? So x over sine x will be changed into 1 over sine x over x. Right, so for that part, we can simply substitute the value of what we call x with 0. So we have cos square of 0 will be 1, right? Alright, so for this part, alright, so you can distribute the limit into both the numerator and also denominator there. So we'll have something like limit as x approaching 0, alright, as x approaching 0 of 1. So this one, limit as x approaching, what happens? Limit as x approaching 0 of sine x over x. Alright, that one cos squared 0 multiplied by 1. So only then you can use the squeezing theorem. Right, please show this step first. Right, the way you change it, right, you invert the x over sine x into 1 over sine of x over x, and then you get marks. Alright, so this one will be limit as x approaching 0 of 1 will be 1 because it's constant there. So this part will be using the squeezing theorem. Okay, this part should use the squeezing theorem. So you will have 1 multiplied by 1. So your final answer will be 1. Okay. Alright, so that's quite interesting. You know, learning calculus is very interesting actually. Alright, so that's number 12. If you have something like this, alright, so again, you want to put this sine x over 3 with x together. So that cos x should be moved to its side. So it will be something like limit as x approaching 0. Sine of x over 3 over x multiplied by 1 over cos x, right? Okay, so the next thing I'm gonna do is actually I want to distribute this limit into these two functions first. So we'll have something like limit as x approaching 0 of sine x over 3 over x multiplied by limit as x approaching 0 of 1 over cos x. Alright, so now we have to do something here because this one is x over 3, this one is x, so you should have 1 over 3 at the denominator. So multiply 1 over 3 at the denominator, multiply 1 over 3 at the numerator. Alright, so now you will have something like, alright, so I'm taking out the, alright, let's say I read it first. Limit as x approaching 0 of 1 over 3 of sine x over 3 over x over 3. Multiply that 1 over cos 0. You substitute the values of 0. Alright. So now you can take this 1 over 3 out there. Alright. So take this 1 over 3. Alright. Take it out. So it will have something like 1 over 3. Okay. Limit as x approaching 0 of sine x over 3 over x over 3 multiplied by 1 over 1. Alright, so 1 over 1 is 1. So this part will be using the squeezing theorem. So the final answer will be 1. Alright, so that one will be 1 by squeezing theorem, and the last part there will be 1 here. So 1 over 3 multiplied by 1 multiplied by 1. So your final answer will be 1 over 3. Okay, so number 13, right? Number 13, you have to do something called factorization here, actually, right? If you try to substitute the value of x with -1, so we'll get 0 over 0 case. So this part should be factorized. Alright, so if you remember, this is actually 1 means 1 square. So you can simply change into, alright, so we have limit as x approaching -1 of sine x plus 1 over x square minus 1 square will be changed into x plus 1 x minus 1. Okay, so please take note that to make use of the squeezing theorem, we want to put this term together. Alright, so we have to take that 1 over x minus 1 aside, so it will be something like, okay, let me change it into this form. Limit as x approaching -1 sine of x plus 1 over x plus 1 multiplied by 1 over x minus 1. So I'm going to distribute the limit. Alright, so we're distributing the limit into these two functions. So it will be something like limit as x approaching -1 of sine x plus 1 over x plus 1 multiply with the limit as x approaching -1 of 1 over x minus 1. Alright, so this part here we have seen in the previous examples, I think in question number 5 or 4, something like that, number 5 I guess. So we have to do the shifting the graph. Alright, so this is actually making use of the squeezing theorem, so the final answer will be 1. Alright, so this part you have to what do we call that, substitute the value of x is -1, so multiply with 1 over -1 minus 1. So your final answer will be 1 multiplied with 1 over -2. So your final answer will be -1 over 2. That's your final answer for this one. Okay, so the last one here, alright. So if we have something like this, so we want to put, always bear in mind, we want to put this sine 7x with 3x, because we want to have it in form of sine x over x. So we try to modify a little bit. All right, so we'll have something like, okay, limit as x approaching 0 of sine 7x over 3x multiplied with 1 over 1 plus 3 cos x. Okay, so now what I'm gonna do is that I'm trying to distribute the limit into these two functions. All right, so we'll have something like limit as x approaching 0 of sine 7x over 3x multiplied with the limit as x approaching 0 of 1 over 1 plus 3 cos x. All right, so we have to do some modifications here. We have to put this 3 out here. All right, so it will be 1 over 3. Okay, leaving only limit as x approaching 0 of the sine 7x over x. All right, and then you multiply with that one. You can simply, all right, I'm talking about this part where you can simply substitute the value of f0, so 1 over 1 plus 3 cos 0, right? Cos 0 is 1, bear in mind that cos 0 is 1. Okay, so you will have something like, okay, so that one is 1 over 3, 1 over 3. All right, so this part has 7x. All right, we have seen quite a lot of examples here, 7x, but this one does not have 7, so we have to put 7 here, but we have to put 7 here. Put means multiply, you multiply 7 there. Right, so you'll have something like limit as x approaching 0 of 7 sine 7x over 7x. All right, so the last part there, you have to calculate the value of cos 0 will be 1, so multiply by 1 over 1 plus 3 multiplied by 1. Okay, 1 over 4. All right, so what we have in next solution is that we are going to calculate this. All right, so 1 over 3. Right, so we take out this 7 out here, so it will be 7 over 3 actually. So 7 over 3, limit of x approaching 0 of sine 7x over 7x. Okay, and then you multiply with that one, you calculate the value will be 1 over 4. So this part will be 1. All right, so 7 over 3 multiplied by 1 multiplied by 1 over 4. So your final answer, when you calculate, you get 7 over 12. All right, so that's basically the 0 over 0 case of the limit using the squeezing theorem. So please recall that you have to memorize the squeezing theorem stated in this box here, where the limit as x approaching 0 of sine x over x will actually equal to 1. All right, so thank you for watching the video. I hope you get some idea of solving the squeezing theorem. So the next video we'll be learning on the limit as x approaching infinity, right? Or simply said as limit to infinity. So thank you for watching.